Hi, in this problem we're going to find the derivative of this function. So because we have a quotient, we're going to use the quotient rule. Recall that the quotient rule says if you have a function f divided by a function g and you want to take the derivative, what you want to do is think of f as your top function and g as your bottom function. So it's the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom one squared. And I think it's important to think of top and bottom, or numerator and denominator, whichever you prefer, because you don't really have f and g in the problem, you have other things. I mean, you can think of this top piece as f and the bottom piece as g. But for me, it's easier to think about location, numerator, top, denominator, bottom, rather than introducing other variables into a problem that already has variables. So let's go ahead and do it. Let's take this derivative. So y prime is equal to, so the derivative of the top is going to require a chain rule. So we have something to the fourth power, so we'll bring down the 4, and then the inside piece is x plus lambda, and then you subtract 1 from the exponent. 4 minus 1 is 3. And then times the derivative of the inside. The derivative of x is 1. The derivative of lambda is 0 because it's a constant. So again, we brought down the 4, left the inside untouched, subtracted 1, and then times the derivative of the inside. We're using here the chain rule, which says you take the derivative of the outside, leave the inside alone, and then multiply by the derivative of the inside. So all of this is the derivative of the first, then times, or the top, the derivative of the top times the bottom, x to the fourth plus lambda to the fourth, minus the top, so that's f, so x plus lambda to the fourth, times the derivative of the bottom. So here we'll use the power rule on the x, so we'll bring down the 4 and subtract 1 from the exponent. That will leave us with 4x cubed. And the derivative of lambda to the fourth is 0 because lambda is a constant, so therefore so is lambda to the fourth. And the derivative of a constant is 0, so we don't write it. All of this is being divided by, wow, it's huge, right? The bottom one squared, so x to the fourth plus lambda to the fourth squared. We should definitely check our work, so let's just go through this again just to make sure there's no mistakes, because we still have to simplify, and that's a habit to get into because everyone makes mistakes. So always just check again after you do it. So let's see, the derivative of the top piece, we're going to bring down the 4, okay, leave the inside untouched, subtract 1, so we get 3, times the derivative of the inside, which is just 1 because the derivative of lambda is 0 because it's a constant, times the bottom, minus the top, okay, so far so good, times the derivative of the bottom, 4x cubed from this piece, and then this derivative is 0 because it's a constant, all over the bottom one squared. All right, so what can we do here? Let's keep going. Y prime. I see that we can do something, but I'm gonna do let's just clean it up and then I'll show you. So I'm gonna make an extra step just for clarity. So this 4 and this 1, they don't both need to be there. I can erase the 1. So I'm going to do that. I'm just gonna write it like this: 4 parentheses x plus lambda cubed, and then x to the fourth plus lambda to the fourth. Just making it look a little bit cleaner. We can get rid of these parentheses and the 1. And then here I'm going to put this in the front just to make it look better. So minus 4x cubed, and then we have x plus lambda to the fourth. And all of this is being divided by this piece here. So it's x to the fourth plus lambda to the fourth, and this is squared. Okay, so I feel that's a little bit easier to work with. So let's see what we can factor out from the numerator. We should be able to find a common factor. So we've got a 4. And then here we have x plus lambda cubed, and here we have x plus lambda to the fourth. So we can take out x plus lambda cubed. So x plus lambda cubed, and then I'm going to put a bracket here. And then we're just basically factoring this out from both pieces. So for the first piece, we already have this and we need this. So that's what's missing. So we have this piece here. Okay, because this times this is what we have here. And then minus, so we took out the 4, so we're left with x cubed. And we took out x plus lambda cubed, so we still have an x plus lambda to the first power here, right? I won't put the 1 there, but it's to the first power. And you can check, right? 4 times x cubed is 4x cubed. X plus lambda cubed times this, there's really a 1 here, right? So you add the exponents. 1 plus 3 is 4. I'm going to erase that 1 though. Okay. All right, and it's all over. All of this is divided by x to the 4th plus lambda to the 4th, and this is squared. And look what happens here. We get some cancellation, right? Boom. Oh, wow. We get a lot of cancellation here, right? And this goes away completely, so we get y prime equals 4 x plus lambda. And what do we have here? We have x to the 4th plus lambda to the 4th, right? Because we can drop the parentheses. Let's go ahead and distribute this one. Minus x cubed times x is minus x to the 4th. And then here we have minus x cubed and lambda. So that'll be minus lambda x cubed, like that. Yeah, very nice. Pretty cool. Let's see what happens. I haven't done this yet, so this is kind of interesting. This is 4 x plus lambda. Okay. And these go away, so that's pretty cool, right? And then we have lambda to the 4th minus lambda x cubed. And I think that's a pretty good way to leave our answer. I mean, you can probably pull out a lambda, but, you know, I think it's good. I like it. Yeah, kind of an interesting problem. Usually in these problems, these quotient rule problems, the denominator doesn't just like go away a lot of times, you know. In the standard ones you typically see, you're left with a fraction at the end, but there's no fraction in this one. Kind of a fun example. I hope this has been helpful to someone. Good luck.